this condition in our diagram that all the subclasses have only one superclass. Usually we call it single inheritance because they will inherit only from one superclass. So this type of form, it is called a tree structure or hierarchy, because they are forming a tree. When you do have the tree, for instance, you do have branches, and for each branch you do have a leaf. صح ولا لا شباب? In an arbor you do have branches, and in each branch you do have a leaf, and those leaf you have only one leaf, أوراق. You cannot have a leaf and then from that leaf will go to other leaves. So we talk about branches, not from the leaf itself. So those leaf are subclasses, and the branch is the superclass. That means all those leaf comes from that superclass. In the other side, when you don't have such constraint like in hierarchy, okay, we said that a subclass can be a subclass of more than one superclass. In this case, we say we do have a lattice form or multiple inheritance, because this is the main difference. Here we do have a single inheritance, and here we do have multiple inheritance. Here we do have only one superclass as a parent of that subclass. Here we do have more than one superclass as a parent of that subclass. So in this case, we say we do have a lattice, not an hierarchy. Okay, and we gave an example okay, of a lattice, specialization lattice, where we do have this subclass engineering manager that does have more than one parent, more than one superclass. It does have a parent of engineer. It does have a superclass manager, and a salaried employee is a superclass also of engineering manager. And we said it is logic that the engineering manager is inheriting from engineer, manager, and salaried employee. Anyone who is inside this box, inside this set, he must be an engineer first, and he is a manager as a role. He's playing a role manager, and he is paid as a salaried or a monthly, for instance. Okay, this is what we mean by a lattice. As we mentioned in a lattice or hierarchy, a subclass inherits attributes not only of its direct superclass, but also of its predecessor superclass. As we mentioned here, for this one, engineer manager will inherit the attributes of engineer and also of the employee. Will inherit attributes of manager and employee. Okay, of course, when we talk here, if you can see here, if we go through this path or this path or this path, all of them are leading to the employee entity. That means when we say engineer manager is inheriting attribute of engineer and employee, it is inheriting engineer, manager, and employee. If you can see, employee is repeated, but at the end you have to put it only once. It will only once, because here we do have intersection of all those with the employee entity. We are not going to reproduce all the attribute of the employee when we follow this path. Then we reproduce the attribute of manager and employee again, and we reproduce, for instance, the attribute of salaried employee and employee. Okay, for the employee we just show it once. Okay, we say that engineer manager is inheriting all the attribute of engineer, manager, salaried employee, and employee attribute and relationship. We said that a subclass with more than one superclass, it is called a shared subclass with multiple inheritance. Okay, so we can have specialization, hierarchy or lattice, or generalization or lattice, depending on how they were divided. Now, when you talk about specialization, okay, we said that how we are going to create specialization. What is the way of creating specialization and generalization? Okay, if you are given something like subclasses or classes, and you are asked to create specialization, so what you will do, you will start with an entity type, okay, at the top. That's why we call here top. Then we define the subclasses of that entity type by successive specialization. So you go to the top one entity, and you create from that entity those subclasses like we did here. I do have on top employee, and from the employee I will try to create all those specializations that are related to employee. So I will go from the top to the bottom down. Okay, I will have secretary, technician, engineer as one specialization, employee on the top. Then I will go to the bottom down. I will create manager specialization. I do have employee on the top, and I will have in the middle or down. I will have, okay, it is recording, good. Okay, so I will have employee and salaried at the bottom. So when you create specialization, we said that we are going from top down conceptual refinement. That means we are looking again at our ER diagram and see whether we have missed some requirement or not. Okay. In the other side, when we talk about generalization, you start with many entity types. It's not like here. Here we started with one entity type. Here we start by having many entity types, and we try to generalize those many entity types into one that will gather or group the common properties of those entity type, like we did what we did last time with our example for the car. I remember. Yes, you see, we did have the car entity on its own. We did have a truck on its own. So these are two entities, two separated entities. Then those two separate entities, which are at the bottom down. So we looked at what is the thing that or those entities have in common. We said that car, truck can be classified as vehicle. Okay, so we just put them into a vehicle, and we look at what are the shared or the common attributes of the vehicle. We do have vehicle ID, price, license plate. This is general, whether it is a car or a truck. And we can have also for each subclass its own attribute. For the car, maximum speed, the number of passengers. In the truck, you can have number of axle or tonnage, for instance. So these are particular properties or particular attributes for truck, and these are particular attributes or characteristic for the car. And those which are on the top are shared between car and truck. All the car and truck have license plate, have a price, and they do have vehicle ID. Okay, when you talk about the car doesn't have a tonnage. We don't say this is a car of 1.5 ton or whatever, based on how much, let's say, that car will hold, for instance. So it does have, we talk about the number of passengers. In the truck, we don't say, I do have a truck of 7 passengers. Okay, so it does have its own characteristic. So when you do generalization, you start from bottom, then you go up. Okay, and this is the way how we create specialization and how we create generalization. Okay, so this is just as a recap what we said for the generalization, bottom-up conceptual synthesis. Okay, now in terms of, we have looked at this specialization lattice. We said with multiple inheritance, it is a lattice because of that student assistant subclass, which has more than one subclass, superclass. It does have employee superclass and student superclass. That's why this specialization is a lattice. Okay, if we didn't have such link of that student assistant, we will have a hierarchy diagram. We looked at the categories or union. We said sometimes, okay, we need to have, for instance, let's say a class or a subclass that is derived or that does have element from many other classes or superclasses. Okay, so that single superclass subclass with relationship with more than one superclass, for that superclass, those superclasses have different entity types. In this way, we said that we are using what is known as a category or union type. That means we are going to create, okay, this is an example, what we have seen in the database for vehicle registration. We said a vehicle owner, with regard to who is the owner of the vehicle owner can be a person, can be a bank, or can be a company. It's like, imagine, for instance, you are working, we are talking about the delivery company, okay, and the company has a policy that you might be, for instance, an employee of that company, and you can use your own car to do the delivery, and they will pay you for fuel, for instance, and they will give you extra money for that because you are using your own car. The company might have the cars that are owned by the company itself. The company has both those cars; they belong to the company. Or the company might have some cars that are bought by installment, but the owner of those cars are the bank, okay, because the company has not paid the full amount for those cars. That's why we said the bank is the owner of the car, okay, or cars. Even the cars are within the company, and the company are using those cars. The company is using those cars, but they still, the ownership of those cars is the bank. So here we do have three cases. When you do have a car inside that company, you have three scenarios. Whether you do find a car that belongs, or cars belong to a person, or a bank, or a company. So here we need to create a subclass that will hold this scenario. Okay, when we say I do have a set, and inside that set we do have some cars, okay, and in our case, or in our scenario, those cars can belong to a person or a bank or a company. They cannot find a car. The owner of the car is the person. It is an employee, for instance, and at the same time it belongs to the company, or it belongs to the bank. It is not logic. That's why we need to show such scenario. Okay, in a real environment, you might have this type of scenario. So the solution for that, to show that scenario within your EER diagram, is what is to create what is known as a category or union. Okay, here in our case, we create a category or union. We called it owner, okay, which represent a subset of the union of the three superclasses: company, bank, a person. Okay, and we said the category member must exist in at least one. Okay, just you typically one. Here, for instance, you do have, by the way, Shabab, yesterday the graph I showed you yesterday, there was an error, and I think someone of you has asked, there was a double line. You remember, Shabab, yesterday?
Yes. Okay,
yeah.
now.
Yes, that double line should be in this side, not on that side. Okay, it should go from, let's say, this class to the circle, like we did with our previous superclass and subclass relationship.
That means, Doctor, all owner have car, right?
Yes.
Clear now. Now we can.
Shabab. That means when you do find, for instance, an owner here, for instance, a car, that car should belong to person, will a bank or company. You cannot have a car without any owner. If we do have double line, if we do have the double line, so not necessarily that means all that, as we mentioned last time, we do have a partial or total participation. So this is an example where you do have, as we mentioned, how do you show a union or category? You put that subclass with the subset symbol, and that circle that will link those classes with the union symbol. Okay, that means this is a category or union. And we said that when you define something here, it belongs to a person or a bank or a company. Like here for registered vehicle, for instance, when you do have the registered vehicle and you do have a union. So now the union subclass or category subclass is the registered vehicle, and car and the truck are the superclass. So this is for representing a union. In regard to last thing in this EER diagram, there are other notation. So what we have adopted in our case, we are adopting this type of notation with EER diagram. You might find other book or other textbook, they are adopting different notations. Okay, and the most popular one is the UML class diagram. Okay, where you do have this type of diagram. Okay, with different types of symbols. It is not our let's say topic in this course, but just for you to let you know that there are other type of notations that can be used to represent to draw an ER diagram. These are alternative diagrammatic notations, okay, depending of the model you are choosing. In our course, we said we are choosing an ER diagram model, ER model. So this we have adopted those previous notation that we have covered in our ER and EER chapter. Okay, so it's just for your own information to know that you might find, for instance, in some textbooks different notation. So it is a common thing. It depends of what type of model you are adopting to show your let's say the scenario or the design of your database. Okay, so what I want you now to do, Shabab, there is an exercise on LMS, then I will share it with you now on screen as well. I want you to start doing the exercise. Okay, I will give you some times to do it. Okay, and we will correct it together, inshallah.